Welcome to the team. So you're a new engineer, right? Let me let you in on a little secret. Writing the code? That's actually the easy part. Today, in this explainer, I'm going to teach you how we actually choose the blueprint to build successful systems. Because here's the reality. If you choose the wrong software development process model for a project, your code is going to fail before you even write the very first line. Here is our game plan for your first mentorship session on the architecture team. We're taking you from basic textbook definitions straight into high-stakes decision-making. We'll cover the core models, build out a decision framework, look at a master comparison table, and then I'm putting you through a rigorous scenario gauntlet to really test your instincts. Let's get into it. Okay, let's jump straight in with the granddaddy of them all, the classic waterfall model. Think of this as your traditional, strictly linear sequence. It takes its name literally, right? Progress flows in one direction, downwards, through the phases of requirements, design, implementation, testing, deployment, and maintenance. Every single phase must be completely finished, signed, and sealed before the next one even thinks about beginning. The output of one phase literally becomes the input for the next. So, when do you actually pull Waterfall out of your toolkit? Only, and I mean absolutely only, when there are zero ambiguous requirements. You need an environment where the product definition is rock solid and the technology is 100% understood. Think of a straightforward payroll system or basic inventory software. If there's even a slight chance your customer might want to change features halfway through, or if you're dealing with a massive, complex object-oriented project, Waterfall's total inflexibility will completely sink you. There's no working software until the very end, so you basically have to be right the first time. Now, what if we take Waterfall and just double down on the rigidity? That's the V model. It's an extension of Waterfall, meaning all those requirements are still completely locked at the start. But it ramps things up by planning testing in parallel with every single development stage. For every downward design phase, there is a corresponding upward testing phase. Because it demands such intense, rigorous verification, this is your absolute go-to when failure is simply not an option. We're talking mission-critical government apps or highly regulated software where downtime is flat-out unacceptable. Let's leave that strict sequential world behind for a second and look at an evolutionary approach. Enter the incremental model. Instead of making the customer wait until the very end of the project to see anything, the system is sliced down into smaller, standalone modules. Build a little, deliver early. If your major, high-level requirements are clear, but you absolutely have to beat a competitor to market, this is your blueprint for sure. You develop and deliver the core functionality in the very first increment. Say you're building an e-commerce app. Increment 1 might just be user registration and a basic product catalog. Boom, it's live. Increment 2 adds the shopping cart. You are prioritizing high-value features and getting a usable product into users' hands fast. Just a heads up though, if your underlying architecture isn't solid, integrating all those new components later on can become incredibly complex and pricey. Now, a lot of people confuse incremental with the iterative model, but they are totally different beasts. While incremental adds new standalone pieces one by one, the iterative model builds a basic, bare-bones version of the whole system right away. Then it refines and improves that entire system in cyclical loops based on feedback. This is an absolute lifesaver when you need to find practical design-related flaws early on. Because you're iterating over the whole system, it's actually surprisingly cost-effective to make requirement changes and fix things on a restricted budget. And that brings us to the absolute heavy hitter of the bunch, the spiral model. Introduced by Barry Boehm, this incorporates iterative loops with those linear sequential phases we talked about, but it places a massive, undeniable emphasis on one specific thing: continuous risk analysis. You deploy Spiral when you are looking at a massive, incredibly expensive project where you're just drowning in uncertainty. High risk, highly ambiguous requirements, this is your choice. In every single loop of the Spiral, you gather requirements, look at alternative solutions, and explicitly build prototypes to hunt down and resolve fatal risks before moving forward. The catch? It requires highly qualified risk specialists, making it literally one of the most expensive and complex models to manage. Okay, as your mentor, I know these exam scenarios and real-world project briefs can feel totally overwhelming. So I've built you a cheat sheet. Memorize these exact trigger phrases, and you'll cut through the noise every time. When you see fixed, you think waterfall. Unacceptable downtime, V model. Early market delivery, incremental. Early flaw detection on a tight budget, iterative. And high risk, always think spiral. Go ahead and take a mental screenshot of this master comparison table. It synthesizes everything we've just talked about. Notice how, as customer involvement and requirement ambiguity go up, you naturally move away from waterfall and push towards iterative and spiral. And check out the budget column. Notice how costs just explode when you move to the spiral model because of all that intense risk mitigation? This table is exactly how an architect balances competing constraints.
All right, it is time for the gauntlet. I promise to make this harder and give you some tricky scenarios where two models look correct at first glance. So let's see what you've got. Scenario 1, you have totally locked requirements for a government app. Do you go with Waterfall or the V model? Keep in mind, both of these rely on locked upfront requirements.
Did you guess Waterfall? It's super tempting because we literally just said government apps with locked requirements fit Waterfall perfectly. But that trigger phrase right there, unacceptable downtime, is the dead giveaway. That demands the rigorous parallel testing discipline of the V model to guarantee stability. Round 2. You're building a massive e-commerce platform. Major features are mostly known, but you are in a flat-out race to beat a competitor to the market. So, incremental or iterative? Both are flexible, and both solve that strict wait until the end problem of Waterfall. What's your pick? The definitively correct choice here is incremental. Why? Because the major features are defined and your ultimate business goal is hitting the market fast. Remember, iterative builds a rough version of the whole foundation, but incremental lets you deliver a fully functioning core module, like that login and shopping cart we talked about, so users can actually use it right now while you build the rest. Okay, this next one is a classic trick question that catches almost every fresher off guard. You're building a revolutionary system, high ambiguity, astronomical failure cost, and it mentions prototyping right in the prompt. So, prototype or spiral? It's the spiral model. I know it literally says prototyping in the scenario, but here's the catch. The textbook explicitly notes that the pure prototyping model requires all risks to be completely identified before you start. But in real life, for a revolutionary system, unknown risks are going to pop up after development begins. Spiral's dynamic, phase-by-phase risk handling is the only way you survive that kind of uncertainty. Let's pivot to a super traditional enterprise scenario where stability is the rule, an academic management system. The tech is completely understood and totally non-dynamic. Perfectly stable project definition. Are you going waterfall or incremental? Yep, it's good old waterfall. With zero ambiguity, highly understood technology, and, crucially, no business pressure for an early release, Waterfall gives you the easiest, most manageable roadmap. Why take on all the integration headaches of incremental releases when you can just follow a simple, well-documented, straight line from start to finish? All right, final test in the gauntlet. You've got a large application, you need to catch deep design flaws early, but your budget is seriously restricted. Both Iterative and Spiral feature those cyclical loops that let you catch things early. Which one makes the cut? If you said iterative, you hit the nail on the head. Spiral is an amazing model, but it is astronomically expensive and requires a whole team of highly qualified risk specialists. The iterative model is specifically tailored to let developers fix deep architectural flaws early on a much tighter budget. It's the perfect, cost-effective choice here. You survived the gauntlet, but before I send you off to your first real project, I want you to keep this in mind. Your exams are going to force you to pick just one strict model, but real-world architecture is more of an art. The source notes specifically call out that, in practice, most large, complex systems are actually built using a hybrid approach, pulling elements from all these models depending on what the team needs at that exact moment. So, now that you've got the fundamentals locked down and you know how to navigate the tricky stuff, I'll leave you with this. Technology moves incredibly fast. Cloud computing, AI, continuous deployment, they're changing the game every single day. How are you going to adapt this foundational thinking to the crazy, rapid-fire projects of tomorrow? Keep questioning the blueprint, and I promise you, you'll build something that lasts.